Hello everyone, this video is covering fractions. This is kind of a crash course on how to add, subtract, multiply, and divide them. One quick thing I wanted to point out here at the front is that addition and subtraction of fractions requires a common denominator. Multiplication and division does not require it, so don't waste your time getting one if you're multiplying and dividing, and don't forget to get one if you're adding or subtracting. Before we jump into fractions, I want to talk really briefly about prime factorizations, because this is going to help us do things like cancel, reduce, even find common denominators. So a prime factorization is just taking a number and breaking it up as a product of prime numbers. Prime numbers, by the way, are numbers that can only be divided by 1 and itself. So like 3 is a prime number because the only way you can multiply to 3 is 3 times 1. Or 7 is a prime number because it's only 7 times 1. 4 is not a prime number because it's 2 times 2. So a prime factorization, you start with your number, let's say 28 in this case, and you want to start breaking it down into pieces. So you start with any way to multiply to 28, which 7 times 4 is one way. Now 7's prime, so I circled it, because that's going to be in our answer. But 4 isn't prime, so you keep doing a factor tree on that. 4 is 2 times 2, both of those are prime, so I circled it. So we just figured out 28 is 2 times 2 times 7. This is what we call prime factorization. Let me show you one more quick example. 180. Start by thinking up any two numbers that multiply to 180. There's several ways you could go here, but they should all work. Let's try 10 times 8. 18, sorry. Okay, 10 times 18 is 180, but neither of these are prime, so we're going to have to make a tree off of each of these. 10 is 5 times 2, and those are both prime, so I'm going to circle those. 18 is 9 times 2, but 9 is not prime. 9 has to go further. It has to become 3 times 3. Oh. There you go. 9 is 3 times 3. And those are both prime. So this is our prime factorization. We just figured out 180 is 2 times 2 times 3 times 3. So 180 equals 2 times 2 times 3 times 3 times 5. Times 5. Right, those are all the prime numbers that we circled. So this is what we call the prime factorization of 180. So we're going to use that prime factorization in a second, but first, basic multiplication is really simple with fractions. You multiply straight across. 3/4 times 1/7, you do 3 times 1, sorry, which is 3, and 4 times 7, which is 28. You always want to see if you can reduce this afterwards, but none of these could actually cancel, so that's going to be your final answer. Now, it's not always that easy because you actually want to try to cancel as you multiply to save yourself some steps. So if we take a look at the second one, because I know some things are going to cancel, like the 3 and the 9 and the 4 and the 8, I'm going to start by actually writing this as one big fraction and factoring everything as I do it. It's going to look weird, but it's going to help us in the long run. So the 3 is 3, and it's times 4 across the top, but 4 is 2 times 2. So I'm going to break it up into primes like that. That's my 3 times 4 right there. Now on the bottom, 8 is 2 times 2 times 2. And again, I'm skipping the factor tree, but if you can't do this in your head, take it off to the side, do a factor tree. That's my 8 right there, 2 times 2 times 2. And I also have a 9, which is 3 times 3. So what I did is I broke all these numbers up into primes, and now I can see what's going to cancel. Like 3 over 3 will cancel, because remember, 3 over 3 is just 1, so that's going to go away. 2 over 2 will cancel, and another 2 over another 2 will cancel. So what I'm going to do is just go through and cancel out pairs of numbers on top and bottom. 3 and 3 cancel. 2 and a 2 cancels, 2 and a 2 cancels. Doesn't matter which 2's, obviously. So what do we have left here, though? Because we just canceled out everything on the top. Well, remember, every time you cancel, you're getting a 1. We actually just got 1 on top. And on bottom, see how we have a 2 and a 3 left? 2 times 3 is 6. So we got 1 over 6. That is the answer to this multiplication problem. So it's kind of weird how in the first step, instead of multiplying, we actually factor things apart. But that helps us cancel and get straight to the final answer. If you did it directly, you'd get, what, 12 over 72, and then you'd have to spend all that time breaking it back into primes to cancel them anyways. Alright, division is very much like multiplication with one extra step. Here are your two, this is kind of your rule up here, so a over b divided by c over d. First fraction stays the same. The division, you change it to multiplication, and the second fraction, you flip it. Notice c over d becomes d over c. So basically we're going to turn all of our division into multiplication and then do what we just did in the last slide. So let's take this first example. 1/2 divided by 5/8. The first number is going to stay the same. Division becomes multiplication, and 5/8 becomes 8/5. Just like last time, we can factor and cancel here. 1, we don't need to write 1 because it's just 1. Anything times 1 is itself. 8 is 2 times 2 times 2. And then on the bottom we have 2 times 5. And you can see a 2 is going to cancel on top and bottom. And so we'll end up with 4 on top, 5 on the bottom. That's our answer there. Right, so notice our rules. We flipped it, and we changed it to multiplication. Then we did our regular division, or sorry, multiplication. 12 divided by 3/4, same idea, but notice we have a whole number. Anytime you have a whole number and a fraction, make your whole number into a fraction. The way you do that is you take your 12 and you put it over 1. Or take any number and put it over 1. Okay, so that takes care of our 12. Now we're going to flip and multiply. So we'll change this to multiplication. And our second fraction will become 4/3. Alright, let's factor and see what cancels. 12 is 4 times 3 and 4 is 2 times 2, so 12 should be 2 times 2 times 3. Remember, don't do it in your head at first. Practice on a factor tree. 4 is 2 times 2. And on the bottom we just have a 3, so I mean it's pretty obvious. Only thing that cancels is our 3. And what we're left with, we have 2 times 2, which is 4, 4 times 2, which is 8, 8 times 2, which is 16 on top. And because we have a 1 on bottom, 16 over 1 is just 16, so our answer is actually just 16. That's the result of 12 divided by 3/4. Okay, remember for addition and subtraction you have to have a common denominator. If you have one, it's really easy. Look at this example. 3/10 plus 1/10 equals 4/10. They're already all over 10, so all you do is add the 3 plus 1 and you get 4/10. Technically that needs to be reduced, but that's just factoring and canceling. So if you don't have a common denominator, that's when it gets a little bit more complicated, but I'm going to try to show you how to do that. And we're going to do it by factoring our denominators into primes and then canceling and balancing them out. So what that's going to look like is we'll start with what we have, our 5 over, and then 18 is 2 times 9, so that's 2 times 3 times 3. That's our 5/18. And the other one, we have 7 over 24. 24 is 8 times 3, so I'll do 2 times 2 times 2 times 3. Those are our denominators factored into primes. Now to get a common denominator, our denominator is going to have the exact same factors. So notice, see how this one has 3 2's and this one only has 1 2? We're going to need 2 more 2's in this denominator. And the way we're going to get away with it is we're going to multiply it in the bottom. That's what we want. But then we have to balance it out by multiplying it in the top. The reason we have to do that is because you can't just change the denominator and have the same problem, right? You're actually creating a different number, essentially. But if you do it on top and bottom, remember 2 over 2 is 1, and 2 over 2 is 1. So basically I've just multiplied this fraction by 1. I haven't actually changed its value. That's how we get away with changing the denominator without actually changing the whole problem or changing the value of the fraction. We'll do the same thing with the 3. So now notice real quick, we have 3 2's and we have 1 2 3 2's. Our 2's are balanced. For our 3's, this denominator has 2 of them, and this one only has 1 of them. So we're going to need another 3 in this denominator. Same thing as last time, we're going to multiply it down there. That's what we want. But to get away with it, we have to multiply it in the top as well. Alright, so now you just put everything back together, because we actually have a common denominator. It is, let's see, this is 8 times 9, it's 72. Right? 2 times 2 times 2 times 3 times 3. Same thing down here. So let's put it all back together. On the top, 5 times 2 is 10, 10 times 2 is 20 over 72. And 7 times, the second one, 7 times 3 is 21 over 72. And when we add these, now that we have a common denominator, it's super easy. 20 plus 21 is 41 all over 72. Right, so that's how you can get a common denominator and what we call equivalent fractions, because I want to point out to you real quick, this 5/18 we started with is the exact same thing as 20 over 72. They have the same value, they just look different. And 7 over 24 is the same thing as 21 over 72. Same value, they just look different. So we make them into these equivalent fractions over a common denominator, then we just combine the numerators. Keep in mind, you always want to try to factor at the end, but I think 41 is prime, so that's going to be our answer here. very similar for subtraction. In fact, everything's exactly the same other than the subtraction step. Let's factor into primes. Our first one is 17 over 30. 30 is 5 times 6, so that's going to be 2 times 3 times 5. And we're subtracting 5 over 12, and 12 is 2 times 2 times 3. Okay, so focus on balancing one thing at a time. Notice we have, let's start with our 2's. 1 2 here, 2 2's here. This one's going to need another 2, top and bottom. Right now, both denominators have 2 2's. Our 3's are already balanced, right? Both of our denominators have 1 3, so we don't need to do anything with that. But we do need to fix our 5's, because there's 1 5 here, and there's no 5's in the denominator over here. So we're going to need another 5 in the right. Times 5 times 5. Okay, notice our denominators are now balanced because we have each denominator has 2 2's, 1 3, and a 5. If you multiply that all together, our common denominator will end up being, let's see, 4 times 5 is 20, 20 times 3 is 60. So it's over 60. And on top we have 17 times 2, which is 34. And our second one becomes 25 over 60. So there we go. We made them into equivalent fractions with common denominators. Now when we subtract 34 minus 25, it's going to be 9. Oops. Over 60. And this will reduce because they at least have 1 3 in them. Let's go ahead and factor them real quick. 9 is 3 times 3, and we already know what 60 is. Remember, that was our common denominator up there. 2 times 2 times 3 times 5. And you can see now that 1 3 will cancel. So our final simplified answer will be 3 over 4 times 5, which is 20. 3/20. Okay, so that's pretty much it. I'm just going to do a quick example of each one again, just to refresh you. This is like your kind of your practice section. I recommend you work these problems first, then watch these videos, or then watch me go through it. So here's the first one. We're adding, so we need a common denominator. I'm going to factor these. 3 over 2 times 2 plus 5 over 2 times 3. This one needs another 2, top and bottom. And this one needs a 3, top and bottom. Right? Let me make some room. So this will give us 9 over 12 plus 10 over 12, and that's going to give us 19 over 12. And 19 is prime, so that is our answer. The second one is division, so that's actually a little bit easier. We're going to keep the first fraction, change it to multiplication, and flip the second one. That was our rule. Let's factor now. 7 times 2 times 2 times 2 over 2 times 5. All that cancels is 1, 2. And we get what is that? 4 times 7, 28 over 5. That's it. Two more quick examples. We have a multiplication where we don't need a common denominator, and then a subtraction where we do. So the multiplication will be pretty easy. We're just going to factor as we combine it into one big fraction. 3 times 2 times 5. Then 2 times 3 times 3. What cancels? Well, it looks like a 3 cancels and a 2 cancels. So we're just left with 5 over 3. There's your multiplication. For subtraction over here, we do need a common denominator. So we're going to start by factoring just our denominators. 5 over 7, 7 is already prime. 1 over 14, which is 2 times 7. You can see we're going to just need a 2 over here. Now they both have 1, 2, and 1, 7 on the denominator. Put it all back together. We get 10 over 14 minus 1 over 14, which is 9 over 14. You could factor this, but 9 is 3 and 3, 14 is 7 and 2, so there's not going to be anything in common. So this is your final answer. So there you go. That's your crash course in fractions. Let me know if you have any questions, and good luck with that.